Hi, welcome to the remote data real-time application group assignment. We are group 7 and the group members are Corey, Feza, and Idris myself. For this assignment, we decided to go with the real-time stock market monitoring application use case. So for this system, we do some analysis on RESTful and graphic REST API and GraphQL usage, and we have then we discuss a bit about the WebSocket for real-time data, and we have our some technology, and we have our diagram. So for this presentation, I will be taking you through the REST API and GraphQL for data request update. Then my colleague Feza will run through the WebSocket for real-time communication. My colleague Feza will run through the WebSocket and real-time communication, and Corey will take over the technology recommendation and certification thereafter the system architecture diagram. So, having said that, so for this real-time stock market monitoring application, we have two distinctive category data interaction. We have a resource-based operation, which perform the CRUD operation. In this case, we have, for example, creating a portfolio, managing alert configuration, authenticating user. And as another data interaction, we have a flexible operation, or the category, flexible category, which is like query heavy read data where client needs to retrieve deeply nested combination of information. In this case, for this system, we have portfolio positioning, market snapshot, is historical price, and so on. So REST API and GraphQL address those two category data interaction in differently. So first of all, we'll talk about the REST API for this stock market monitoring application. So REST API is actually ideal for performing operating or performing some operation. So it is stable and do some resource-based operation. So where endpoints are map clearly to a specific resource. So we have identified some resources in this case, which are the user resource, the portfolio resource, and alert resource. So those are the resources that we'll be identifying, and some also admin resource. And we also came up with some endpoint that we potentially think that will be the app or the system will be consuming this endpoint to predict this REST API function. So here are some, and all these REST API we actually performing this. You are create, read, update, delete using some HTTP method. Using the HTTP method, post, get, put, and delete. So the advantage of using REST API on this system are mainly catching data, simplifying the fetching and collecting information from a resource point or from a resource perspective. Where we have our resource, we can use HTTP method to collect information about a specific resource. Interoperability, which is like integrating with an existing system with other system. And we also have scalability. So those are the advantage of using REST on this system. So although we are using REST API on this system has some advantage, but also have some limitation. And one of the limitation is what we call overfetching or underfetching. So overfetching, let's talk about overfetching, is when, for example, we just need a portion of information. For example, we just need like a portfolio price, and we have to make the entire portfolio request to get a specific information, and which is like time consuming and increased latency and necessarily data it necessitates data transfer from the server back to the client. So to overcome this limitation, this is where we introduce GraphQL. GraphQL is based for complex reads where UI needs a different combination of data depending on the screens or the client's needs. So in this case, we like, for example, we have a dashboard where a client needs a portfolio quote derive metrics together, and GraphQL can just in one query and one round trip can perform this operation. Oh yeah, so this is an example of what we're actually referring to. So we have our dashboard. We create a query that will load the dashboard where we only have one query that is treated as one operation, and that will be requesting this information: total, value, daily, positioning, to the server, and he return only the information that you need. So this query is very simple, whereas if you had to do this query using REST API, we had to do 40 separate service call or service operation using REST API. So yeah, this is what we say. It eliminates overfetching information. So yeah, the advantage of using GraphQL in this case are, like I mentioned, no overfetching information, a single round trip information instead of making different endpoint to the resource. We have our strongly typed schema and client caching, but the client caching is also mentioned as a limitation because limitation of GraphQL in this case, because performing a caching on GraphQL is quite very hard and not as easy to implement compared to using REST API. I will then hand over to my colleague Faiza, which will take us through the.
In REST and GraphQL, client initiates every time data exchange. And here comes the benefit of WebSockets by providing full duplex TCP connection that is bidirectional and with low latency. Useful for, in our case, for price tricks, fluctuations of portfolios, and time-sensitive alerts for users. So for WebSocket connection lifecycle. So one client opens WebSocket connection and authenticates, server validates token, registers, and then subscribes the client. Price events flow from market data ingestion service through Kafka and into WebSocket server, which finds out price to subscribed clients. The heartbeats ping pong frames are exchanged every 30 seconds. And WebSocket scaling WebSocket connection. So we can have WebSocket horizontal scaling connection to keep WebSocket layer stateless. And here we can see on the table comparing WebSocket to other alternatives. We can see that it has a very low latency, it's a native server push, it's bidirectional, and it has a medium scale complexity.
All right, this is our recommendation and justification for the technology we'll be using for this application. Uh, we'll use a combination of all three of them. REST specifically for the authentication and writes to our database. GraphQL just to handle all the multiple stock portfolios that we'll be receiving for our dash view. WebSockets for that real-time streaming, especially for the live price changes. Justifications Rust is makes it simple for our writes. GraphQL is there mainly there to avoid our overhead and underfetching for the multiple stock portfolios, and WebSockets for that real time data flow. There was an option to do polling for the external market, but this is a real live application. This is where I feel it was best to use. In our technology stack, we have an API gateway mainly for the rate limiting and routing. REST API is best for the event-driven architecture like this one. GraphQL is best here to handle multiple data sources going to a single endpoint. Our WebSockets for that real-time application. Uh, Maybe you can even use Socket IO for the best fallback support. And then we have a mesh EQ with Grafka, specifically for handling all the price changes, all the price events coming from the external market. Portfolios and user data will be handled by MongoDB. For our front end, our clients will be using React for their and React Native for their respective web and mobile versions. Here is our architectural design. From our front end going to the GraphQL, um, it will be talking to the REST API. Here in this diagram, it doesn't show it, but it should be talking to the event bus to get information from the external market more readily, as it's going to be there to hold out the portfolios from the database as well as all the incoming and extra data from the external market. And then with our REST, we're just going to be able to create alerts and being storing them into MongoDB from the REST API. Afterwards, we for our WebSocket feed, we're just going to have a live price feed being sent from the external market and then to a WebSocket server that will ingest and normalize all the data coming in and publish into that message queue. The client WebSocket will consume these events and then send it to the client, as well as any alert notification being sent through here. For we do have some Azure services that we can use for all these examples here. We have the API management, web pub sub, event hubs, Cosmo DB, as well as some monitoring. That would be it for